Voyager 2 is slowly running out of power. After nearly 5 decades in space, one of humanity's most successful spacecraft is entering the final chapter of its incredible journey. Launched in 1977, Voyager 2 was originally designed to explore the outer planets. It flew past Jupiter and Saturn before becoming the only spacecraft ever to visit Uranus and Neptune. But its journey did not end there. Voyager 2 kept traveling outward, deeper into the unknown. In November 2018, it crossed the heliopause, the boundary where the Sun's solar wind gives way to the surrounding interstellar environment. For the first time, humanity had a spacecraft directly measuring conditions beyond the Sun's protective bubble. And what Voyager found was not a simple boundary. The region was dynamic and complicated. Magnetic fields change. Plasma behaved differently. Energetic particles moved through the environment surrounding the solar system. Voyager 2 was effectively taking measurements from a place no human being could physically reach. But now, that extraordinary mission is facing an unavoidable enemy: time. Voyager 2 depends on radioisotope power. Its energy supply slowly decreases as the radioactive material inside its power system decays. Engineers therefore face an impossible balancing act. Every year, there is less available electricity. Every instrument consumes some of that limited power. So NASA has been gradually shutting down systems that are no longer essential. The spacecraft survives, but with fewer scientific capabilities. And that creates a frightening possibility. What if Voyager 2 detects something important just before it loses the ability to tell us? The spacecraft is now more than 13 billion miles from Earth. At that distance, communication is painfully slow. A command can take roughly 19 hours to reach Voyager 2, and another 19 hours can pass before a response arrives. There is no instant control. No technician can simply restart a failing component. Every command must be carefully planned. Every signal must be interpreted with caution. We saw just how fragile this communication can become in 2023. A command caused Voyager 2's antenna to temporarily point away from Earth, disrupting communication. For a spacecraft this distant, even a small mistake can become a major problem. Eventually, engineers detected the faint signal and restored communication. But the incident demonstrated something important. Voyager 2 does not have to physically break apart to disappear. It only needs to lose enough power, communication capability, or scientific instruments. And as its systems are switched off, the spacecraft becomes less capable of explaining what it encounters. That matters because Voyager 2 is one of only 2 spacecraft currently providing direct measurements from beyond the heliosphere. Its observations are unique. Its location is unique. And its data cannot simply be replaced. The spacecraft has already sacrificed some of its scientific capabilities to preserve power. Each shutdown extends its operational lifetime, but also reduces the amount of information it can collect. Imagine trying to understand an unfamiliar environment while gradually losing your instruments. That is essentially what is happening to Voyager 2. It is becoming a quieter witness. But remarkably, it is still listening. Its remaining scientific systems can continue studying magnetic fields, plasma waves, and energetic particles. These measurements could help scientists understand how the solar system interacts with the enormous environment between the stars. And somewhere beyond the heliosphere, Voyager 2 continues traveling into territory humanity has barely explored. The spacecraft may be aging. Its power may be fading. But its journey is not finished yet. Because the most important discovery of Voyager 2's mission may still be hidden inside one of its final measurements. And that is where the story becomes even more mysterious. Voyager 2 may be slowly dying, but its final years could still produce scientifically valuable discoveries. The spacecraft is now operating in an environment that no other mission has explored in exactly the same way. Beyond the heliosphere, the Sun's influence becomes weaker and the surrounding interstellar medium becomes increasingly important. This region is not empty. It contains extremely thin plasma, magnetic fields, energetic particles, and waves moving through interstellar space. Voyager 2 can measure some of these invisible phenomena. And those measurements help scientists understand where our solar system ends, and how it interacts with the galaxy around it. But Voyager 2 has a unique advantage. It is traveling through a different direction from Voyager 1. Voyager 1 crossed the heliopause in 2012. Voyager 2 followed several years later. Because the two spacecraft entered interstellar space at different locations, scientists can compare their measurements. That gives researchers something incredibly rare: two distant witnesses observing different parts of the same enormous cosmic boundary. And the results suggest that the heliosphere is far more complicated than a simple bubble surrounding the Sun. Its boundary can change. Its shape can vary. Its interaction with interstellar space can produce complex effects. Voyager 2 has helped scientists understand that the region outside the heliosphere contains physical conditions very different from those inside it. But every new measurement now comes with another question. How much longer can Voyager continue? Its power supply is declining. Its instruments are being turned off. Its communication system is aging. Eventually, engineers will have to decide which remaining systems deserve the last available energy. This is the painful trade-off. Keep more instruments operating and the spacecraft may lose power sooner. Shut instruments down and Voyager may survive longer, but with less scientific capability. Eventually, there may be only a small number of systems still operating. At that point, Voyager 2 will no longer function like a complete scientific observatory. It will become something much simpler. A distant listening station. A final pair of electronic ears pointed toward interstellar space. And what might those ears detect? Perhaps another change in the magnetic field. Perhaps a new plasma wave. Perhaps an unusual population of energetic particles. Or perhaps nothing unexpected at all. But even an ordinary measurement could be valuable because scientists have very few direct observations from this distant environment. There is also a fundamental challenge. When Voyager sends an unusual signal, scientists must determine whether it came from space, or from the spacecraft itself. An aging electronic component can produce strange behavior. A weakening power supply can affect performance. A failing instrument can create misleading readings. So every mysterious signal has to survive one critical question. Is this the universe, or is this Voyager? That question will become increasingly important as the spacecraft grows older. And once Voyager 2 finally stops communicating, humanity cannot simply send another spacecraft to replace it. A new interstellar probe would require years or decades to reach a comparable region. For now, Voyager 2 remains our distant representative. When its final signal eventually arrives, it probably will not contain an alien message or some impossible discovery. It may be nothing more dramatic than another measurement of magnetic fields or plasma. But even that final measurement could become part of humanity's understanding of interstellar space. Because Voyager 2 has already accomplished something extraordinary. It crossed the planets. It crossed the heliopause. And it carried human curiosity into the space between stars. One day, its signal will become weaker. Then weaker again. And eventually, Earth will hear nothing. The spacecraft will continue drifting through the galaxy, carrying its message and its golden record into the distant future. But its scientific voice will be gone. And that is the real warning. We are not losing the universe. We are